Hi everyone, thanks for joining today's webinar. We'll get started in 1 or 2 minutes just to allow others to join. So thanks for your patience. Hi again, everyone. For those who have just joined, we're just going to give it 1 or 2 minutes to allow others to join. I can see there's quite a few people joining, so we will start in 1 or 2 minutes. So we will be with you shortly. Thank you. Hi folks, thanks again for joining. We'll just give it 1 more minute just to allow others to join. I can see there's people slowly coming in, so we'll start in 1 minute. Thank you. Okay, I can see quite a few people in. So to keep the time, we might get started. Hello again, everyone, and thank you for joining us today for our joint HashiCorp NGINX webinar titled Dynamic Load Balancing with Consul and NGINX Plus, which will be presented by David Wright, Technical Channel and Alliances at HashiCorp, and Rajesh Bhavanantham, Solution Architect at NGINX. So today, Dave and Rajesh are going to show us how to use HashiCorp tools for provisioning and connecting services like NGINX in a multi-cloud environment. The presentation and demo should run for about 30 to 40 minutes, and then we'll open up at the end for a Q&A. So all going well, we may finish up earlier than expected. But yeah, during the presentation and demo, if you do have any questions, please submit them via the Q&A tab at the bottom of your screen there, and we'll get to those at the end. And finally, I'd like to note that this session is being recorded, and we'll send out an email with a link to that recording within the next day or two. So that's it from me. So let's go ahead and get started. Over to you, Dave.
Thanks, Pete. So in this presentation, we'll talk about some high-level elements around the modern networking and what modern networking really means. We'll talk about some of the concepts around how Consul helps in that scenario and where it fits in. We'll talk about some drivers that are making changes within the industry. And then we'll look at how specifically, with the help of Ragesh's demo, we can take a practical look at how these elements integrate in with a load balancing solution such as NGINX to actually then interact and become this gateway between, in a lot of cases, the new world and the old world. And so with that in mind, what's driving a lot of these criteria and a lot of this pressure is organizations are now focusing on digital transformation. Digital transformation has become, or has always been for the last few years, a really big buzzword. Now, obviously with this year, COVID has driven a lot of digital transformation and forced organizations to look at new ways to become relevant to their customers, new ways to embrace digitally as a lot of the face-to-face elements have been taken away. And all of these pressures have created this secular motion, because what we've seen, and this is both in my time here and working in other cloud platforms, is that organizations that start to embrace a digital transformation come up against or get exposure to this new way of working. That new way of working allows them to experiment. It allows them to develop new features quickly. They see this new and increased way to time to market. They see a mechanism that they can get a better experience, particularly digitally, with their customers. And what that tends to do is then, as they start to experiment, they get to like what they can achieve. They see development cycles shortening. They see amount of releases increasing, and they want to then develop that more. And that creates this circular motion where the business is starting to put more demand, and we want to be able to run all of our applications within that time frame and within that scope. And that puts pressure on the organization to then actually change more and more workloads. Now, as we'll talk about later, one of the problems with that obviously is that not all workloads can move to the cloud. And then how do you solve the networking components of that? And so, as I said, we've seen this element where this increase in this digital transformation and looking at ways to innovate, we're seeing a real pressure on applications. And the application space and the developers are now taking more control and more ownership over building, deploying networks. They are programmatically deploying infrastructure. They are now becoming, with the SRE teams and the cloud operating teams, these mechanisms or these groups are now becoming more and more responsible for being able to deploy and connect those well together. And all of those adds to challenges and makes life a little bit more complex than it used to be. But then there's also the added element that those developers are now looking at ways that they can push that digital journey closer to their customer base, whether that's across the world or within different countries. How do they improve that customer experience? How do they improve that digital integration? And a lot of this is being focused around, I think, a great example of this is where the battle for the banks used to be how many shop fronts they had in the high street, how many banks that they could actually service customers. Now that digital battleground is very much around who has the best app on their phone. So applications are now really starting to drive what the requirements are for infrastructure and how infrastructure needs to be tied together. What this means is that in the old world, and this is where this modern and old world networking comparison kind of really comes from. In the traditional networking elements, where there was a very strong on-premise or solely on-premise component, you had a very defined set of applications that lived within a very set boundary. So you had your physical boundary of your data center. Traffic flows were very clearly controlled. So traffic had a point of entry and point of exit, usually the same. There was clear IP boundaries, clear routing rules. So my background comes from networking. We used to use IP boundaries to segment application domains to be able to segregate and control where users could go. We had, even very rudimentary routing rules to be able to black hole elements so they couldn't get somewhere. And all of those elements meant that you had a lot of control. You knew and could clearly define where all of your elements and network boundaries were. You knew what the subnets were. You knew what the VLANs were. I'm very ashamed to admit I can still remember a lot of the IP addressing from some of the customers that I worked with for a long time. But in the new world, obviously that changes. And so in that new world, you have this area where IP addressing has become dynamic and is outside of your scope of control, so you don't even know what that dynamic range could be. You have resources spinning up. You have those resources spinning up in different areas. And so how do you connect those different areas together? You could have a developer who has written an application that needs to be spun up across the globe, right? Also, the difference being is there is now, with the move towards containerization, serverless, and microservices, there's this large volume of east-west traffic. So this traffic between those applications and those smaller services to actually drive API communications and to actually build up what the overall customer experience is. And so now not only have to think about how you can control and manage all of those complex environments, but you also have to think about how you can connect them together. And also that connection can be different, right? So if you're connecting across multiple cloud platforms, the mechanism to do that is different within each of those. It's using a common technology, but the way that you do that and the way that you have to control that is then unique. And so all of these things tie together to create this new thinking in what modern networking is, but also the new challenges around loss of control and loss of and this ability to have to be able to think, how can I do this at scale without necessarily being directly involved in those configuration changes. And this is where Consul really comes into its own. And this is where Consul as a tool focuses around delivering kind of three key elements. And in the journey that we see with customers, those three elements fit across the crawl, walk, and run thinking that HashiCorp's philosophy really ties to. And so the service registration is that first early stage and is usually the first part that needs to be established. Then integrating with existing networking equipment, so whether that's existing firewalls or existing load balancers in this case, and being able to actually start to get some of that automation and discovery into those existing networking components. And then once you have a good understanding and a good integration across your networking, be able to then tie that together to create this a full-blown service mesh with zero trust, and start to use intentions and layer 7 observational rules to be able to apply security across that environment. And so Consul is one of our largest services. We're seeing over a monthly 1 million downloads. It's used at scale. So, it's used across a lot of banking, gaming industries, and a lot of large scale entities where they have deployed this volume. And we're seeing it being used to deliver this single control plane. And as I spoke about earlier, that single control plane is very much focused around understanding the different elements, putting in a single point of control across those elements, and then being able to actually tie them together and steer and deliver an actual outcome or application or point-to-point connectivity. But the focus is around having a control point that allows for interoperation with different platforms, different environments. We work with lots of different ecosystem partners to be able to tie those together to have this united networking component. And that means that then you can integrate in our ecosystem partners. You can work across different cloud platforms. You can integrate with containerization. You can integrate with non-container components or serverless elements. And the great thing with Consul is when it is deployed as a cluster, it doesn't have to be run within a Kubernetes environment. It can be run anywhere as a binary. And because of that, you can then bring in or pull out or pull in traffic into that cluster to connect existing infrastructure. And this is where a really valuable part of this story around the unified solution comes in, is that you can have a hybrid scenario and you can use Consul to connect that hybrid into your new cloud world. So if we look at how that integrates in the next part of that journey, the first really important part with integrating with our network infrastructure is to define our single source of truth, so our central registry. And so the single registry creates this directory or for the networking guys, it's your DNS component, because that's fundamentally what's driving this underneath. But it's your single service registry where all of your new services can be are discovered and registered. And so once you have and know where services are and leverage the ability to understand, are they available? Do they pass the health check? And being able to put a context around it, i.e. this service is Web 1 and is in Asia Southeast, and this one is in AP Southeast 2, you can actually start to build up an awareness of where those services are, how to actually migrate them, how to get services close to the users, and how to actually be able to get them to deliver outcomes. And so once you have that service registry, you can then use that to do discovery. And so what the service discovery enables you to do is now define a particular service. So now we're defining and describing not just an IP address, but we're defining an actual service. So we're giving a point, an endpoint or node. We're defining a particular name for that endpoint. We're giving it a port number and can associate a health check with that. And so now that you have that service, very similar to the member concept within F5. So the pool member is an IP address and a service. So that thinking around creating an actual service endpoint. Now we have our service that we can actually understand where to send traffic to and define how those services, once it's in that central registry, can talk to one another. Another important element, obviously, particularly in that network automation part, is Consul templates. Now, Consul templates are a third-party mechanism that allow for Consul to create a template and use a template file to actually pull data into that file, create a full-blown rendered configuration of what that configuration file should look like, and push it to an application, or in this case, pushing it to an actual device. And so what happens is when we write that template, it will push to NGINX and actually trigger a reload. So you can actually start to interact and create change based off of what Consul knows is that from the service registry and service discovery. And so when we look at that service registration perspective and what service discovery will do is, in a cluster, you have two elements to it. So firstly, the NGINX component could talk to other services. So this could be a front end, and it needs those back-end elements may need to talk to database components across that, or different middle tier or microservices to actually interact with. And so they can be automatically discovered, and all of them use this automatic service discovery, which can be an agent run within them, could be a configuration element, could be it's all driven automatically through the Consul agents. And so they register into that Consul cluster. All of these things can then talk to one another, regardless of how long they live, whether ephemeral, spin up, spin down time. And so once you have the ability to talk across those services, you may also want to be able to add in some of those a new capacity. So we have the ability to talk across from the middle tier, but if a new app server needs to spin up to deliver for capacity, again, Consul can discover that. It can create a Consul template for that, and then actually force that template down to the NGINX, which creates a reload, and now you have additional pool members into that. So if we take a quick look at an example of that NGINX template, you can see here that we've defined what the server is, but some of those elements are programmable components that we pull in from the automatic service discovery, so that this allows for that context to be completely automated. And so as new nodes get discovered, we can add them automatically. It creates that template. And now we have this, this automatic feedback loop that creates all of those changes dynamically. And some of these elements is what Rajesh will go through in his demo. So with that, I'll pass it over to him to actually talk through his demo and explain some of those, what he will be showing you.
Sure. Thanks, David. David, if you can show the next screen where I would explain a little bit about the high-level design of what I'm about to show. It's good. Thank you. So actually, Dave pretty much took me back in time. Probably 10 years ago, I would have not able to do this by my own. I would have to, rely on network engineers, security engineers to, do the networking between two different data centers. So what we are going to realize today was, it made it very simple with the tools like a Consul, NGINX, and Terraform. It was quite easy to do that integration between the tools and also between two different data centers. So in this case, as you can see, I have oversimplified this, but the way how it's going to be deployed is I have chosen GCP today to deploy this environment. I'm not going to use NGINX Plus as a load balancer. I'm going to use NGINX Plus as more of an API gateway where you can get more than what a load balancer can do. So I have a bunch of services here, which is deployed scattered across both the regions. I have selected Singapore and Australia to deploy that, and also we run a Consul cluster across these two regions. The GitHub location for this one will be shared along with the email which you're going to receive. You can pretty much go and do whatever I'm doing it today by yourself with very, very simple changes. So what I have done is I have terraformed it by using Terraform, and then Consul is used. I try to use Vault a little bit, but it is too late. So maybe I'll improve it once I'm get out of this one. But what you're going to see today is Terraform is actually going to deploy the NGINX Plus, Consul, and some few microservices into different environment, different regions, and we'll go from here. So this is just an NGINX Plus dashboard where you can see how many services deployed. I didn't want to actually deploy this live because it will take 10-15 minutes. So I thought I'll just prepare it in first place. So this the way how NGINX Plus is working, it's actually trying to talk to Consul to get the upstream endpoints dynamically. I'll also highlight the Consul endpoint, Consul UI, what Dave actually showcased. So here it gives an inventory of the services, whatever we are running as of now. We have 3 Consul services, and we have microservices, 3 of them. All of them actually I have deployed as 3 instances on each region. Weather service, even NGINX Plus API gateway is deployed as 3 instances as well. So let us actually check the same in Australia Southeast as well. It is the same thing. So it's, the same endpoint has been replicated using Terraform. Just to make sure that we are doing it live, what I'm going to do is I'm going to actually size it down, all the microservices to 1, just to prove that we are doing this a live demo. While this is happening, let us get into the code of whatever Dave actually explained. I'll go through how I have realized it. So let's take an example of a microservice. It's an hello service. What I've done is, as part of this one, it actually get deployed as an image. It is available. It will be available at the time of deployment. So when I create the image, I will make sure that I have the registration JSON file as part of it. So this is what the Consul expects itself to get registered to it. So you can define some of the tags here, what type of language you're using, and what's the version you're using, what type of port you're using, and even you can do a health check you can configure with the Consul. So once this services actually get deployed to one of the VM, and it will automatically get registered to the Consul server. So this is from a service point of view. Then go into NGINX Plus. NGINX Plus itself, a client, then it can also get registered to the Consul. So while it actually doing it, NGINX Plus as an API gateway, it is actually deployed with a Consul client. So the way how it actually picks up the upstream endpoint is pretty much dynamic. We are using the SRV record to do that. Most of the things are available as part of the open source. The only thing what it doesn't available as part of the open source is this. You can't have the status zone. That means you can't see like, what's happening on the each one of the server zone. I will explain it when I actually move into the UI of it. So here what I have done is for this particular upstream API, I have pointed to the local Consul client pointing to this 8600 and also just trying to pick up the service, what I have registered from the microservice itself. So just showing the example of F1 API or Hello API. So this is an endpoint which actually get resonate with this one. So it actually goes and looks for it, and then it actually pulls up all the IP address associated to that bit. I hope we have deployed it. Let's go and check. There you go. So as you can see, initially when we were looking before it, every one of them had 3 instances. Once now I reduced it to single instance of each microservices. Now it's actually going down to 1 of them. And let us actually check on the Singapore as well. I mean, the other region where we deployed, to make sure that it is deployed. So it's pretty much a repeatable process. Once we share the GitHub location, you should be able to do this by your own, by just giving your own GCP account and deploy this on your, on your intention, how you wanted to do this one. So, from NGINX, from the Terraform point of view, it was pretty straightforward. I have actually created as like a 3 different modules. One of them actually deploys the Consul server. The other one deploys the microservices images, which is already should be available already in the GCP repository, and then the NGINX Plus instances. Just to be clear, the only reason I'm using NGINX Plus here is to highlight what as an API gateway it can bring to the table. It can be used with an open source NGINX Plus NGINX as well to use it against the Consul. So since now we have deployed all the services, I wanted to make sure that the services are deployed fine. The services are pretty much, they are secured using Auth0. It's actually, it needs a JOT token to do it, but let's actually test whether that actually works or not. So if I try to actually, hit the endpoint of a Hello NGINX Plus API, it actually clearly throws me an error saying that you don't have right access to go through it. So with an access token, if I actually get the access token, there you go. So this particular scenario can be actually utilized in different method. Currently, I've only deployed at a single cloud provider. This can be expanded to a multiple cloud as well, just by opening up the IP addresses between 2 different cloud providers. Currently, it's only restricted to talk between the regions in a single cloud provider, which is quite easy to do it if you really wanted to do it with the multiple cloud as well. If you really wanted to actually go and do that as well, please reach us to us. Probably ourselves and HashiCorp can do a specific demo or specific POC for you guys if you're really interested to solve this problem in a multi-cloud environment as well on your desired cloud. Doesn't matter whether it's an Azure or AWS or even an on-prem, you should be able to do it quite easily. By bringing NGINX Plus, you can pretty much do the same thing by clustering between multiple cloud and multiple regions, and still make sure that you are able to apply the right level of policies across all these cloud environments as well quite easily. So one thing which I didn't do what Dave was talking about is using the Consul template. The reason for that is as I mentioned, I wasn't using this as a simple load balancer. I just upped the game by bringing more API gateway functionality into the picture. So that's one of the reasons I didn't use the Consul template. There's a lot of customers actually uses it for even for their sidecar approach as well, where they run NGINX as a sidecar, and it can actually retrieve the information from the Consul and apply it dynamically on the fly. So in this particular case, what I have done is I have created the image. The image is pretty much ready to be highly scalable in a way how you want it to be. We can, it depends on if you really wanted to see that demo in person, please reach us to us. We are happy to give you a POC jointly between us and HashiCorp. Thank you. Over to you, Pete. I don't know whether I actually rushed, but I think I'm in time.
No, that's good. Yep, right on time. We're at 1:30 now, so we're way ahead of schedule. Thanks for that presentation and demo, Rajesh. Really nice work. Now I'm just looking to see if we've got any questions in the Q&A tab. I can see there's a few there. I'll read them out in a moment. But if you do have any questions, please drop them in the Q&A tab there, and we'll answer them right now. So just looking at the questions we have, we've got a question here for both Dave and Rajesh. You guys can jump in. Large legacy organizations that still dictate point-to-point network firewall rules present challenges to the new world of dynamic IP address allocation. Does Consul help to transition from old static firewall rules to modern dynamic approaches without compromising network security?
Yeah, I'm happy to take that one. I mean, the short answer is yes, it does. So that was easy. No, so to put a bit more context around it is because when you create or get to the point where you can create a full-blown service mesh, so that end-to-end mutual TLS, you're effectively tunneling all of those communications. And so as long as your firewall rules allow for that gRPC and mutual TLS connection to be established through them, then Consul has Consul Enterprise has this mechanism called intentions, and intention is then service-based ACL. So web can talk to mid-tier or API can talk to database can talk to API, but web can't talk to database. So you can build those service intentions into that, and now you have that layer of security in the new world that goes through and connects those elements together through the existing firewall elements. Now, if you want to then bring, an existing database, for example, into that world, so in that intention world, you can use an ingress or a egress gateway and leverage that to actually bring that into the service mesh or pop traffic out, and you now have that bridge between connection to the old database world and the connection into the service mesh.
Great, thanks, Dave. Got another question for you. How does a multi-DC, multi-data center Consul deployment handle an outage to a whole data center or region? Is there some form of quorum?
Yeah, so obviously built into Consul is the health checks anyway. And so if you lose a DC, it will effectively just not send traffic to that DC or those services that are lost within it. You can also do things such as layer 7 traffic steering. So you can actually do things like weighted robin. So you could push traffic to particular data centers. So if you're doing a blue-green deployment or canary or one of those methodologies, you could actually start to feather traffic into a particular DC. But from a data center outage and DR perspective, or HA's perspective, sorry, highly available perspective, the health checks across those services are key to then say, well, those services are gone and I won't send anything new or any requests to that service.
Great, thanks. Here's another question. Would this deployment add additional delay as there are multiple hops to reach the microservice? So would this deployment add additional delay as there are multiple hops to reach microservice?
I can answer that one. No, not really. It's actually historically, how we do realize this is we tend to put load balancers in front of those microservices if we normally do without a discovery tool. So that actually adds much more on this one. So this particular thing, what it does is the microservices get registered automatically at the time of startup to the Consul, and NGINX being API gateway, it can quickly pick up that on the fly. So now there is no hops in between your NGINX API gateway and your microservices. So actually, it reduces more. That's why I quite like this approach of not, if your environment is really dynamic, you're running hundreds of services, then you can reduce the cost and also reduce the hops between your gateway and your service.
Great. It's good. We've got quite a few questions coming in, so I'm pleased, and please hang on and listen to the answers, or drop off, but we'd love you to keep joining us. So another question here is, open source NGINX doesn't support SRV records. Does Consul support A records for service discovery to support open source NGINX?
That will be your question, Dave. I think it's around HashiCorp. Does it support A record? In my knowledge, I don't think so, but you might know it better.
And Dave, you're on mute.
That was lucky because I was scratching my head and swearing. I don't know. So because fundamentally Consul is using a service record in terms of port and IP, I don't know whether you could then use that in without a service port, for example, and or even create just an A record for it to work. I mean, the node is defined as an endpoint service. So, yeah, I don't know. It's something I'd have to actually play with. I don't think so, if I'm fair, but I can't give a definitive answer around that one, to be fair.
Yeah, and look, as well, we can pull a report of all these questions as well and get back to you individually and add more context. So we'll do that as well. We've got a few more questions if you're happy to hang on, guys. Here's another one. Many of the examples I've seen using Terraform and Consul assume relatively fast, short duration HTTPS requests in an environment where you have long running requests. Any thought on graceful exit of old containers services based on connection draining? It's a long one, but do you want me to read that again?
Yes, just trying to digest the question.
Yeah, so many of the examples I've seen using Terraform and Consul assume relatively fast, short duration HTTPS requests. In an environment where you have long running requests, do you have any thoughts on graceful exit of old containers services based on connection draining?
Yeah, it's if I understood it correctly, it's when the moment you get into this kind of environment, cloud native applications, you need to have a stateless idea, because as you said, it's ephemeral. The containers and everything is, it's we really don't know at what point it actually goes down, and when the Kubernetes controller would even bring this particular container down, and it brings up the new container. So it's in my opinion, in that kind of environment, so such a dynamically changing environment, it's better not to have the state stored in the kind of tools like this one. But having said that, the tools like that, whenever the new containers or new VMs get scaled up, scaled down, I just did even a demo of it. Whenever it does happen, it is well integrated with tools like a Consul. It's able to quickly, dynamically fix those things and get reflected back into tools like NGINX. So there is no time gap or anything between that. So if you're only talking about from an infrastructure point of view, I don't see a challenge there. But if you're talking from an actual consumer request, HTTP call comes in, and then it actually served for a long running thing, then you may need some kind of a tools like, BPM tools or something, where it actually you store, play and store your, store and play your request for a long running process.
Yeah, I think that just to add to that, I think it's also around your container management, right? So you can put things in place that would mean that if there are connections or particular number of connections, you can actually put safeguards in place to make sure that the service doesn't start draining off. Obviously, that doesn't allow for things that break. But if you're worried about like service, maintaining service and service life cycle, then you can manage that by putting in controls to actually say, well, don't bleed this off until there's no connections, or put some level of control around the actual container component. But again, it would be around why are you doing that, and some of those points that Rakesh talked to. Is that the best way to do it? Is that actually provide scalability? Do you really need it to be long-lived, or do you just need individual calls to service the individual stateless connections? So there's that way. Is it the right way? Is it necessarily the right way to be doing it, and is that the right way to can you handle it other ways?
Cool. I think we've got time for another two more questions, if that's okay. There's a follow-up question to one of the questions earlier I asked, which was, how does a multi-DC Consul deployment handle an outage to a whole DC or region? Is there a forum of quorum? They've gone on to say, but how will Consul control plane service a request if it is in the DC region without the quorum?
So this then would speak to where so just read that again, Pete. Sorry, if it's
but how will the Consul control plane service a request if it is in the DC/region without the quorum?
Gotcha. Right. So so we have 3 DCs. One of them falls off. How does a request within that DC that's broken out of the cluster answer? Well, then that would be a case of, if the DC is still surviving, which it should be, because it should be built around a HA and highly scalable mechanism and 3-node quorum, then it will be able to answer that locally. So if there was a local service in DC1, and DC1-web asked for DC1-DB, then that cluster would be able to actually respond for it. If it asks for obviously DC2-web, then it will not respond with that answer, because it's not federated across to the other clusters. So it will be able to service local requests within that isolation, but not across, obviously, for things outside of that. The outside world obviously would not see it either, because they wouldn't be able to talk to that DC1. So DC2 and DC3 would be able to answer for each other, but not for anything in DC1.
Great. All right, look, we've got one more question and then we'll wrap it up. So here's another question. One of our curly use cases for Consul was a Java application that stored node lists in its database, along with the node status and type. Does Consul have the capability to replace that IP hard-coded style of node management? Some apps have.
And that's fundamentally what Consul templates will allow you to do, yes. So cool. that ability to take dynamic information, create it in a prearranged scripted form to create a template, render that template into a configuration file, use that configuration file. That's Consul templates use case exactly.
Cool, great. And I can see others have joined in the chat and answering questions of other guests, which is great. All right, folks, we might wrap it up there. Thank you so much for your time today, and so good to see so many questions coming in. And if you do think of other questions or have questions that you've asked that we missed, you can reach out to David and Rajesh on those email addresses you can see on your screen there. So do reach out to them. Like I say, I'll send a follow-up email with their details after this. So with that, folks, brings us to the end of our session today. We hope you found it useful. And as I mentioned earlier, this session was recorded. I'll be sending out a follow-up email with a link to that recording, as well as a link to some other related content. But if you do like what you heard and you want to learn more about Consul and NGINX, I encourage you to visit both our Learn pages. There's the learn.hashicorp.com page where you can dive a bit deeper, as well as the nginx.com/learn site. Again, lots of great information there. But as I say, you'll have these links when I send a follow-up email within the next couple of days. So thanks again for joining us. Big thanks to our presenters, David Wright from HashiCorp and Rajesh Bhavananthan from NGINX. That's it from us. Thanks again, and see you at the next webinar, hopefully. Enjoy the rest of your day. Thank you.
Thank you, guys. Cheers.